Alright, so this is a quick video on estimating square roots. It's not that difficult, but I do want you to do it without a calculator because the goal is to get close, not to have the exact answer for what the square root could equal. So what you're really doing is making an educated guess. Again, we're not going to use a calculator here. You're going to use your number sense to make a guess about what the square root could equal. So I would be a little lenient on the answers that I'll take on your homework. There's 3 steps to this. The first thing you want to do is identify the perfect squares that are just bigger and just smaller than the radicand. You don't want to go way out bigger and smaller. You want the one that is just bigger and just smaller. You want to figure out where the radicand is in relation to those 2 perfect squares. Is it closer to the bigger perfect square? Is it closer to the smaller perfect square? Is it exactly in the middle? That will depend on the decimal that you approximate your square root out to. And that'll make a little bit more sense when we do a couple examples. But then step 3 is to make your educated guess. And we want to take this out to just one decimal place, the tenths place. So here's our examples. We have 3 of them. And we want to approximate the value of each square root to the tenths place. So we're going to look at the first one here, the square root of 30. Well, the perfect squares that are bigger and smaller are 25 and 36. 30 is closer to the 25. That means my decimal is going to be 5 point something. 5 because 30 is bigger than 25 and the square root of 25 is 5. The square root of 36 is 6, and it's not bigger than that, so it's not going to be 6 in a decimal, it's 5 in a decimal. Now 30 is closer to that 25, so it's going to be less than 5.5, so I'm going to guess 5.4, and that would be the approximation that I come up with. Now, it is really close to being in the middle, so if you guessed 5.5, I would also take that. If you approximated it out to something like 5.8, I would not take this because 5.8 would imply that that radicand is closer to the bigger perfect square, closer to 36. So let's look at 50 now, the square root of 50. Well, the perfect squares that are bigger and smaller than 50 are 49, that is the one that is smaller, and the one that's bigger is 64, and 50 is between those two. This tells me that my decimal approximation is going to be 7 point something. 7 because 50 is bigger than 49 and the square root of 49 is 7. Now 50 is a lot closer to 49 than it is to 7. It is 1 bigger than 49. So my guess, my approximation is going to be just bigger than 7. So I'm going to say 7.1. Hopefully that's making a little bit of sense, and we're just using number sense here. Again, we're not trying to be exact, we're just making a guess, an educated guess on our number sense. Last one here, square root of 78. Now, the perfect squares that are right around 78 are 64, that's the one that's smaller, and 81, that's the one that's bigger. I know 78 is bigger than 64, and the square root of 64 is 8. So I'm going to do 8 point. 78 is a lot closer to 81 than it is 64, so I know this is going to be bigger than 8.5. It's really close to 81 actually. It's only 3 away, so I might approximate this as 8.8. Now again, we're making a guess, so if you said 8.9, I would take that. I would probably also take 8.7. These would be okay answers. You've got a little bit of margin of error here that I will give you some leeway in since you are approximating. Something like this one though, the second example, I'm really only going to take 7.1 because 50 is so close to 49. I could maybe take 7.0, but that would imply that our radicand was 49 itself, and it's not, it's 50. So we should approximate that out to 7.1. Those are your examples. You have a short homework assignment over this. Good luck, and let me know if you have any questions.